Hey everybody, Mr. Kowalczyk here. So today we're going to start Unit 5, and Unit 5 is going to be all about quadrilaterals. Quadrilaterals are four-sided figures. We've got 5 lessons here, including the review, and we have 1, 2, 3 topics in our one standard for Intro to Quadrilaterals. Okay, so let's go ahead and jump in to Lesson 1. And in this lesson today, we're going to focus on Standard 9.1, which is I can use the properties of parallelograms to identify and solve related problems. So today we're going to be talking mainly about parallelograms. Okay, so our opener for this one is line U is parallel to line V. So we know that these two lines here are parallel. And that tells us that our third line here is going to be our transversal. And you're asked to find all the measures of the angles, not just the question mark. So go ahead and pause that video and see if you can figure out all those angle measurements. Okay, go for it. All right, so in this situation, what I know is that 66 is going to show up here again because it's a vertical angle. And then 66 is also going to be here because it's alternate interior. And then it's also going to show up here again as a vertical angle. Now my 66 is going to be supplementary to this angle here because they're a linear pair. So then I need to think about what's 180 minus 66 to do that math. Okay, so I get 7 minus 6 is 114 degrees. 114 degrees. Now that's going to show up here as well because of vertical angles, and that shows up here as well because of alternate interior angles are congruent when we have parallel lines. And then over here we have 114 degrees as well. Okay. All right, so those are all 8 angles in that system. Moving on to our notes. Okay, this unit is going to be all about quadrilaterals. Our last unit focused on triangles. This is going to be about quadrilaterals. Now, a quadrilateral has the following properties. There's a couple things that make quadrilaterals. First off, it has 4 sides. Okay. Next, it is 2-dimensional, which is length and width. Doesn't have any depth to it, so it's completely flat. It's closed. All the vertices meet, just like triangles. And finally, it has straight sides. No curves, okay? No curves at all. So those are the 4 different properties that give us a quadrilateral. A quadrilateral is going to be like the big descriptor of all of them, just like with triangles. And then with triangles, we had different types of triangles. We had isosceles, acute, scalene, and a whole bunch of others. Now, in this particular unit, we're going to be talking about 8 different types of quadrilaterals. And for today, what we're going to be mostly focusing on are parallelograms. So let's just list all of those 8 different types so you know what's coming. So the first one is going to be that quadrilateral. So that's going to be a 4-sided figure. After that is going to come a parallelogram. Then we'll deal with rhombus. The plural of a rhombus is rhombi. Rectangle. Square. Trapezoid. A special type of a trapezoid called an isosceles trapezoid. And finally, a kite. So those are our 8 types of parallelograms that we're going to focus on over the unit. Today, we're just going to focus on parallelograms. Okay. All right, let's flip on over to the next page. Now, parallelograms, it's a special type of parallelograms that has parallel sides. Okay. Of course, it has 4 sides because we're talking about quadrilaterals in this unit. And there are, for the case of what we're going to be working on today, I want you to focus on 5 important facts about parallelograms. The first one is that parallelograms have 2 pair of opposite and parallel. See, this symbol here means parallel sides. And the way we mark that up is by indicating that we have parallel sides. Now notice this says one arrow and these have two arrows. Remember, that means that all of the lines or segments with one arrow are parallel, and same thing for two arrows. Just like our congruency marks, we have to have the same number. Our second fact about parallelograms is that they have congruent opposite sides. So what that means is that our opposite sides are exactly the same length, and these opposite sides are exactly the same length. That's cool and helpful to know. All right, now the other thing about parallelograms is that they have congruent opposite angles. And I'm going to use two different colors for this. So we've got this angle being congruent to this angle, and then we also have this angle being congruent to this angle. All right. Now next, parallelograms have diagonals that bisect each other. So what does that mean? Well, diagonals, oh, we're off the camera here. Diagonals are, they connect the opposite vertices. So here we have one diagonal, and here we have a second diagonal. And what happens is this point right in the middle, it splits both of those in half. So that means that this piece is congruent to this piece, and it means that this piece from here to here is congruent to this piece from here to here. So they bisect each other. Oh, I have two number 5s here, so let's go ahead and cross that one out. The last thing about parallelograms is the other way that we can know that we have a parallelogram is by if we have one pair that's both parallel and congruent. So what I mean by that is if we have just these two sides here being both parallel and congruent to each other, that tells us that this diagram, this figure, is in fact a parallelogram. Okay? So we've got our 5 facts about parallelograms. Let's go ahead and solve 1 or 2 of the practice problems, and then you can do the rest yourself. Okay? All right, now, the first question says, determine the missing interior angles of the parallelogram. Well, we know that this is a parallelogram, A, B, C, D, and we also know that we need to figure out what the angles of the parallelogram are going to be. So in this situation, what we know is that these lines are parallel here, and these lines are parallel here also. So the opposite angles in the parallelogram are going to be congruent. That tells me that angle C is 65 degrees. But how do I figure out the other angles? Well, this is something cool about parallelograms also. Because these two lines are parallel, if we go back to our unit on parallel lines, if we think about it just like this, where we have 2 parallel lines and a transversal. If this angle is 65 degrees here, how do we know what that angle is right there? Well, we know the relationship between this angle and that angle right there is same side supplementary, same side interior, and then therefore they're going to be supplementary. So 65 plus some angle here has to be equal to 180. So that means that 180 minus 65 is going to equal 115 degrees. So that tells me that this angle here is 115 degrees. And that's the same situation here because we have a transversal and we have 2 parallel lines. So this is 115 degrees, and therefore this is 115 degrees also. So in a parallelogram, the adjacent angles are going to be supplementary to each other. Adjacent means the ones right next to. Opposite angles are going to be congruent to each other. Okay. All right, now let's do number 3. You can do number 2 on your own. Number 3 says find the perimeter of the parallelogram given that AB is 42, AB is 42, and BC is 53. All right, now perimeter is a word that we may not have talked about so much this year so far, but perimeter, hopefully you remember, is the distance around the outside of the figure. So in that case, if you were to start at point A and walk to B to C to D and back to A, it would be the total distance that you walked all the way around. Well, we only know 2 sides of the parallelogram, but what we learned earlier is that the opposite sides of the parallelogram are congruent to each other. So that means this is 42 and this is 53. So what I can do is I can add up to get all of those together to get the perimeter. So the perimeter equals 42 times 2 plus 53 times 2. So then the perimeter is going to equal 42 times 2 is 84 plus 53 times 2 is 106. So the perimeter is going to equal 84 plus 106. That's going to give me, oh my gosh, 190. Oh, 190. And I don't have a unit here. So what that's going to mean is I'm just going to write units because I'm talking about distance and I need to include my units. It doesn't tell me if it's feet or meters or what, so I'm just going to abbreviate that as units. All right, y'all, we'll stop there for today. Finish up the practice problems in class, and I will see you next time. Bye.